Thank you, Mr. Tonko, and thank you, Madam Chairwoman, for convening today's panel. Given the impacts of PFAS in our communities and communities across the country, and particularly in New Mexico, it's vital that we advance coordination and advance science and research on the impacts, cleanup, and alternatives to PFAS in order to address these issues. In New Mexico, we have had devastating impacts from PFAS contamination, especially in Curry and Otero counties in the eastern side of our state, where PFAS was used as in firefighting foams at Cannon Air Force Base that has led to contaminated drinking water supplies, private wells, and wells that supply dairies in the Ogallala Aquifer, and also contamination at Holloman Air Force Base, which has led to extensive groundwater contamination. PFAS has also been detected in water bodies throughout our state, and we are just beginning to scratch the surface and understanding the full picture of this contamination, the fate and transport of the contaminants within our communities, and the impacts on environmental and human health. Our dairies in particular, and the dairy industry is one of our leading agricultural industries, has been just devastated. Thousands of gallons of milk have been dumped and people's livelihoods have been destroyed by this contamination. So my question is really to Drs. Jaffe and Sunderland, which is how can we expedite and increase the speed of our understanding and our ability to measure these contaminants and to do remediation, especially in areas where there's been large-scale spills?
I'll start with how can we detect them, and perhaps Dr. Jaffe can take how can we remediate them. I think, so in terms of understanding and detecting PFAS, I think support for joint collaboration between EPA and NIST is essential. So we need standard methods that fully capture all of the compounds that we know are used in commerce, and we're innovating on those detection methods and making sure they're usable in the field. And I think another component of this that you touched on is just understanding all the different types of PFAS sources. So there are efforts underway, to integrate PFAS accounting into the toxic release inventory and other databases. And those, I think, with support from all of you, those efforts could be accelerated. I'll yield to Dr. Jaffe now.
Thank you for the question. So when we look at PFAS remediation, right now, most of our efforts are site-specific, where we have high concentrations of PFAS. When you're concerned about agricultural processes, dairy farms, we probably have very dispersed, very low concentration of PFAS. They may have been applied with sewage sludge, and that's much, much more challenging to remediate these large sites. We need to have more focused research. It could be the Department of Agriculture that focuses on how to make these PFAS less bioavailable so they don't go back into the food chain, and how we may be able to sequester them. And there could be methods depending on which one that you could mobilize the PFAS a little bit more so that they get out of the root zone. We don't have a good methodology to address that right now.
Thank you to both of the doctors. It's just so urgent that we expedite this research and development and then expedite the cleanup of these communities. As I said, it's been economically devastating and also just devastating to these communities. So I appreciate the work that you all do. I'm heartened to see that the administration is helping to coordinate this work through the Office of Science and Technology Policy. And I look forward to getting NDAA passed and advancing and supporting this committee's work on this effort. So thank you very much. And thank you to Representative Tonko for yielding, and I yield back.